Hi, Calculus, and welcome to 4.5. We are almost done with this chapter. This one here is the derivatives of logs and natural logs, those type of things. There are rules to follow. There are also proofs in here, which you will never have to reproduce in this class, but it's still good for you to see. So make sure you got 4.5 out, and let's go. All right, we're going to do the derivatives of logs and natural logs and some absolute value functions. So here we go. The rule for the derivative of a log base a of x, it's equal to 1 over the natural log of the base times the function x. So the proof for this, if you have log base a of x, first you rewrite this. So this means this is a to the f of x function, remember, is equal to x. Okay, so you rewrite without the log. So the log is now gone. Now you take the derivative of both sides. So you already know the derivative of base. You know that that's the natural log of a times f of x, or times the original, a f of x, times the derivative of the function. Well, this is equal to the derivative of x, which is just 1. Good to this point? So now that you have that done, we have to do the chain rule. So the natural log of a times the derivative of this, so it's the natural log of a, should be written like so, times x, because that's my original, right? Times the derivative of x is still equal to 1. Well, this means if I had to solve for the derivative, I have to take 1 and divide it by the natural log of a times x. And that's how you get to this formula up here. I know you're probably not very interested, but I still think they're really kind of cool. All right, then the same thing is true for the natural log, except now that's going to cancel out because it's natural log, right? Because the natural log of itself is 1. So that's why it's just 1 over x this time, because this part actually goes away. All right, so we know that the log base e of x, so then you would rewrite, so this is 1 over the natural log of e times x. Well, the natural log of e is 1, is what we were talking about. So nothing too exciting with that proof. So let's move on. Let's do some work with this. We've got the function is the natural log of 6x. Okay, now remember, the natural log of 6x means the natural log of 6 plus the natural log of x. We break this up. That was our log rules from a while ago. Now we have to do the natural log of both, so the derivative of both. So the derivative of the natural log of 6, well, that's just a number. So that's 0. This guy is going to cancel out. Now the derivative of the natural log, remember, is 1 over x. So that's just 1 over x. So the derivative of the natural log of 6 over x is literally 1 over x. Hopefully you can use that and remember that, and you don't ever have to do that again. So f of x is equal to the log of x. So the derivative now is equal to the natural log of the base. Remember the natural log of the base here is 10. So it's the natural log of 10 times x, because it's 1 over x. It's always the natural log of the base times the x. Okay, we want to find the following, the derivative of the following. So take your time. So we know this is the natural log of 7 plus the natural log of x. Well, the derivative of a number is 0. The derivative of natural log is 1 over x. So the derivative of f of x is 1 over x. Done. This one. So now we're using our rule that we just learned. So this time it's 1 over the natural log of the base, which is the natural log of 5, times x, which is just, let's write it like this. We could put the x in the front, or if you're going to put it behind, make sure you use parentheses because it's not the natural log of 5x, it's the natural log of 5 times x. Two very different things. So be careful with your notation there. Okay, chain rule. Natural log of x squared plus 1. I'm going to break this down into u's. If you can do it without, that's fine. So we're doing the natural log of u, and x squared plus 1 is what u is. So now I know the natural log of u, so the derivative of y with respect to u is just 1 over u. Derivative of u is 2 over x. We have to multiply these things, which is 1 over u times 2 over x. Replace our u with what it originally is, and it's x squared plus 1. So what we really have is x squared plus 1 in the denominator, and 2x in the numerator. So what you did, if you remember, this is 1 over x, so it's 1 over the original, times the derivative of the function, which is 2x. You can do that in one step. You are more than welcome to. Okay, so let's pause and find the derivative of log base 4 of 5x plus 3x cubed. I'll do it the long way, just so that you're okay. So we know u is equal to 5x plus 3x cubed, and we're going to let y equal log base 4 of u. All right, so we know the derivative of u is equal to 5 plus 9x squared, and we're going to know the derivative of y. Oh, I don't want to write it that way. I'm just going to write right prime, even though that's not quite right. Here we go. So the derivative of the y is equal to 1 over the natural log of the base, ln of 4, right, times the u. And the u we know is 5x plus 3x cubed. All right, so that's what we got for our derivatives. So now we have to multiply our two derivatives together. So we take this derivative times this derivative. So the derivative of y with respect to x then is 5 plus 9x squared all over the natural log of 4 times 5x plus 3x cubed. Kind of long and ugly, huh? But all is good. Next one. This here they're putting in here to make you understand. It's the exact same rules. That when you have the natural log of a times x, right? Absolute value is here because remember you can't have negatives. So they're just making sure that our domain is correct, which is the same thing with the natural log. Again, you can't have negatives. So it's still 1 over x. Nothing's changing here. They're just making sure you're looking at your domain. Here, same thing. A of g of x. So it's 1 over the natural log of a times g of x, and then you multiply by the derivative of the function in the numerator. Again, making sure that your derivative is okay. It exists. So here's an example. We almost kind of ignore that. So we got 3x and the natural log of x squared are the two things we're looking for. So we're going to take 3x times the derivative of the natural log of x squared plus the natural log of x squared times the derivative of 3x. Well, 3x, the derivative here, remember the derivative of the natural log, is 1 over this times the derivative of the function. So it's 1 over x squared, your original, times the derivative of the function, so the derivative of x squared is 2x, plus natural log of x squared, and the derivative of 3x is 3. Now you look at these things, and we got 3x times 2x over x squared. Well, that's really 6x squared over x squared, which reduces down to 6. And nothing changes here. I just put the 3 in front so that we did not make the mistake of thinking that's x squared times 3, because that would be incorrect. All right, pause and try yours. So now you're going to do the derivative of y with respect to x. So it's the derivative of the first, which is 2x times the second, the natural log of 3x, plus the derivative of the second. So the derivative of the natural log of 3x is 1 over 3x times the derivative of the function, which is 3, right? All right, times the original, x squared. So what we have here is 2x, natural log of 3x. Well, the 3's cancel here. The x's cancel. And we have plus x. Okay, I hope you did a good job. If you have any questions, make sure you're posting them or send me an email. All right, doesn't this guy just look lovely? He is really quite evil. So we have to do the quotient rule with the log rule. All right, so we got to take the derivative of this entire numerator. We have to figure out what that is. And I'm just breaking this down into steps because it is so large. So now we know the derivative of a base, so it's the natural log of 8, times the derivative of the function itself. So you're taking the derivative of t to the 3/2, which is 3/2 t, subtract 1, and you get to the 1/2 power. So that's where this came from, 3/2 t to the 1/2. Okay, and in the denominator, you have the original, t 3/2 plus 1. Now all I did was multiply this through, 3 to the t/2, natural log of 8, times 2, times t to the 3/2 plus 1. Probably should have put the 2 in front to make that clear. Or make sure you're doing your parentheses very carefully. So now we have to do the quotient rule. So it's the derivative of the first, which just came from here, times the denominator, minus the original, times the derivative of the denominator, which is 1, all over denominator squared. Nothing too major. Ridiculously ugly, but nothing too major. All I did here was multiply the t times the t to the 1/2, which gave me t to the 3/2. And I'm going to be done here because I really don't care if you can simplify that any further. There's nothing too major and nothing that we'll gain from doing so. So that can be finished. Ugly as it is, I think you've done enough work. All right, pause and try yours. So now you're finding the derivative of s with respect to t. So you have to do the derivative of the numerator. So we know the derivative of the natural log is 1 over t squared minus 1 times the derivative of the function, which is 2t. All right, so we took the derivative of the first times the denominator, which is t plus 1, okay, minus the derivative of the denominator, which is just 1, times the numerator, natural log of t squared minus 1, all over the denominator squared. All right, when you're looking at this, hoping you're recognizing a few things. So we've got t squared minus 1 down here. So let's work with this guy right here. All right, we know that t squared minus 1 is really, I'm going to put the 2t in the numerator. So I got 2t in the numerator, t plus 1 in the numerator, but t squared minus 1 is t plus 1 times t minus 1. So your t plus 1s are going to cancel, and you are left with 2t over t minus 1. All right, there's nothing we can do over here. So this is just minus the natural log of t squared minus 1 all over t plus 1 quantity squared. It would actually be okay here. I wouldn't care if you finish this one or not, but it's not bad practice. You have three terms here. You've got your 2t over t minus 1. You got the natural log of t squared minus 1, really over 1, right? And the t plus 1 squared over 1. What is your common denominator? So if we took this guy times t minus 1, numerator, denominator, the same here. All right, now remember all of your denominators cancel, and you're left with 2t minus, I'm going to put the t minus 1 in front so we know it's not part of that natural log, t minus 1 times the natural log of t squared minus 1 all over t plus 1 quantity squared times t minus 1. All right, if you stopped here, I'm totally okay, but the green is just a good practice. Good luck, post questions on your homework, and next we have tests.